Hello, and welcome back to the Carbon Capture Magazine podcast. I'm your host, Danielle Piekarski, and today we are joined by two guests, both from the Great Plains Institute, Matt Fry, Senior Policy Manager, and Ryan Kammer, Carbon Management Research Manager. Thank you both for joining me, and welcome back to the podcast.
Yeah, thanks for having us.
Of course. So we've had you both on the podcast before discussing what it means to be carbon management ready and also discussing GPI's Atlas of Direct Air Capture Opportunities. Since we've last had you on, GPI has released a carbon capture co-benefits report. Could you share with us what all is covered in this report and what GPI's objective was in releasing it?
Yeah, so we're really hoping that we could kind of provide the message that carbon capture is more than just a climate solution. It can also improve air quality around various sources in both industry and power. When you're using an amine-based solvent for low purity carbon capture, you're typically wanting to also remove SO2, NOx, and particulate matter from your system so that it can work optimally. And in doing so, that you're also improving the air quality for both the area around the facility, but then also across the country and across regions as air travels. So we really wanted to quantify what that health benefit would be for removing CO2, but also SO2, NOx, and particulate matter for facilities across the country.
And I'll just add, we get questioned a lot about the benefits outside of climate solutions, or like Ryan mentioned. So this was a first of its kind opportunity to actually quantify that and answer some of the questions that we hear routinely from communities and stakeholders.
Great. Thank you both. So, Ryan, you had mentioned some of the different pollutants that are included in the research. It also spans across several industries. What materials or regulations did you observe to help develop this report?
Yeah, there were too many sources that we used to kind of design the study itself to talk about here, but there were a couple NATL reports that were really impactful. One that was published in 2019 that was looking at carbon capture for coal power plants, and then one in 2022 surrounding various industrial capture opportunities. Those were really helpful for us to kind of understand what equipment we would assume to be installed for these various opportunities, as well as what the estimated costs and the estimated removal efficiencies would be for removing these various co-pollutants. Finally, we wanted to be conservative with the estimates that we were making so that our health benefits would also be conservative. And so what we did is we decided to use equipment that would meet the EPA's new source performance standards, specifically for pulverized coal technology installed post-2011. They have the highest allowed emissions amounts. And so by doing that, we were hoping to be conservative with our estimates.
Very interesting. Okay, so how do those co-pollutants impact amine-based capture systems?
Yes, we know that there's potential impacts to amine solvents as they'll prefer or potentially react with NOx and SOx and in particulate matter. The NOx and SO2 can react with the amine solvent and form heat-stable salts, and the particulate matters can actually form, they'll actually gunk up and clog an amine solvent system because of the solid formations that occur within the system. So we know that this is challenging for a number of reasons. When the amine solvent reacts with these other particulates and chemical elements, it degrades them. It can also form into things called nitrosamines and nitramines. Additionally, it causes the producer or the utilizer of the system to have to replace the amine solvent, which is very expensive. So they try very hard to reduce these co-pollutants from the flue gas stream that enters the CO2 or the carbon capture facility.
All right. And to quantify the benefits of capturing CO2 and these other co-pollutants, your team developed an approach. Can you walk us through this approach and what exactly the benefits were that you were quantifying?
Yeah, so I guess I'll kind of start with what our results were. So we identified a representative facility for each sector. So we had 7 different sectors, and we had 10 regions that we identified a representative facility for. So in the end, we ended up with 54 facilities. These facilities are representative for each sector. Notice that there's 16 missing from 70. That's because some facilities or some sectors didn't have either a facility present or a facility that met all of the different requirements that we had for our study. That these are things like being eligible for 45Q, having the available emissions data. So as we were looking at these different facilities, if we're going to quantify what the emissions reductions would be, we'd need to know what the starting point was for NOx, SO2, particulate matter, and CO2. And so if it didn't have those, it really couldn't be a representative facility for our study. Additionally, the NETL reports that I mentioned earlier note that if a facility is already capturing CO2, that would change the system design in ways that we couldn't necessarily get into here. It'd be much more specific to a facility. And then finally, any facilities that had already been announced for closure or had announced that they were going to be reducing operations, those facilities we didn't want to include in our set of facilities either. So once we had kind of eliminated everything that we didn't want to have as part of our representative facility pool, we then selected a representative facility for each sector, meaning there'd be a cement facility in the Southeast and in the Midwest and one in the Mid-Atlantic if there's a facility or multiple facilities that meet all of our requirements. We chose one that was kind of the median or was the median CO2 emissions amount to kind of give an idea. This would be kind of the middle of the road opportunities for reductions for that facility type in that region. Once we did that, we then applied the emissions reductions for CO2, SO2, NOx, and particulate matter 2.5, specifically to now give us the amounts of reductions that we would see at a facility that we could then use with both our system that we had for developing costs, which was called Concord. It was part of the team that we worked with from Carbon Solutions LLC. They have a tool that provides costs of both the carbon capture, but then also parts of the co-pollutant removal. So we now have the performance for evaluating that process, but then also the emissions reductions that we can then use with EPA's COBRA tool, which provides what the health impacts and economic value of those health impacts would be for each facility. And this was done in a way that both quantified what the health benefits are in the region or within the area of a facility. But we know that air quality travels, or air emissions and different things in the air travel. And so it also then identifies what the economic value of the health benefits, as well as what the reductions in different health impacts are in regions throughout the country from that facility's reductions in emissions.
And so through this approach, what conclusions were you able to draw across the nation and across each of these industries that you observed?
So the first that I think is worth noting was just seeing that there's a lot of variance in not only CO2 emissions from a facility type, but also these other co-pollutants. And so the potential for co-pollutant removal and the health benefits associated with that are pretty substantial throughout the country and throughout each sector. And it's likely going to vary by facility and by sector. On top of that, there are certain parts of the country that have maybe more significant health benefits from the facilities that we identified. But this could be both just because of the nature of the size of the facility that we looked at, but also the populations around those areas. So places of the country like the Mid-Atlantic, the Northeast, and the Southeast all saw the most significant health benefits, but they also have large populations. What was interesting, though, was that, as I mentioned, how air quality travels or emissions travel, was that those parts of the country also have regions around them that also have high populations. And so for some facilities and for some sectors, the impact and the positive health impact and health benefits that are seen at sometimes were close to 50% not in the region. And so both showing that there is significant value to removing the emissions at a source for the communities around that facility. But there's also a lot of opportunity on how that facility and other facilities in the region could also better or improve the air quality for other regions. The last thing to note was just that every region and every sector that we identified and evaluated had positive health benefits. Even if the scale was pretty significant between smaller facilities or certain sectors and the large facilities, it was still good to see that there were health benefits and there can be health benefits for all the sectors that we looked at.
Thank you, Ryan. Yes, so lots of really valuable information, and it's a very thorough report. I do recommend that all of our listeners go check it out at the Great Plains Institute's website. One last question for you both here. How do you anticipate this information will affect the deployment and the public perception of carbon management systems?
Thanks for that question. I'll just say, to start off with, as an organization, GPI, we don't advocate for any specific project or entity or industry. So we're not actually producing the report like this to advocate or, if you will, amine solvents to be deployed as carbon capture technology. What we did hope to do is fill a void, an information void. Lots of questions and concerns about what the potential impacts to human health are specific to installation of carbon capture technologies. A lot of information or misinformation out there that these technologies themselves increase health impacts for folks. So we just wanted to develop a methodology that actually quantified the facts that installation of carbon capture facilities specific to this research, amine-based solvent capture facilities, can improve air quality, improve health quality across affected communities. So that was the goal, was to fill an information void and hopefully help inform the public so that they can have more informed conversations as these projects deploy across the country.
Thank you, Matt. Again, today we are joined by Matt Fry and Ryan Kammer of the Great Plains Institute. We are coming near the end of our time here. Did you two have anything else that you'd like to add?
I'll just add one more thing. This is first of its kind research. We need to learn a lot more about these technologies. As new technologies come online, we should learn more about other opportunities and benefits of the other capture technologies that will come to market scale in the near future. So I would just say this is a seed to learn more in the future.
Yeah, and I'll just add that beyond the full report on carboncaptureready.org, there is also a 2-page fact sheet for those who are interested in kind of just digesting something a little bit shorter and can be shared maybe more easily. Those are both available on our website.
Well, thank you both again for joining us on the podcast today. It was great to talk with you both again.
You bet. Good talking to you. Take care.
Yeah, thanks for having us.
You are welcome, and thank you to our listeners for tuning into today's podcast. We hope that you enjoyed this episode and look forward to next time. Until then.